Welcome to part 4 on Intro to Angles. In this video, we're going to look at arc length and area of a sector. In a circle of radius r, the length s of an arc that subtends a central angle of theta radians is s equals r theta. And the area A is the sector where A equals 1/2 r squared theta. Now, here on the right, we have a sketch where A represents the area of this sector that's kind of a pizza shape, like a slice of pizza. We have a positive angle theta rotating through, where the center is the vertex for this angle. The radius is given as r, and if we wanted to find the arc length, that's s, and it's like the crust on the pizza. It's the outside edge where it's curving around or subtending the center of the circle. If angle is 2 pi, that means theta equals 2 pi. And the radius is r. So if we wanted to find the area is going to be 1/2 r squared theta. So let's substitute in these values. We know that 1/2 is just part of the formula. The radius is r, so we'll just write that as r squared. And we know that the angle in radians is going to be 2 pi. Now we know that a standard area for a circle is pi r squared. So let's see if that comes out the same when we actually reduce this thing. If we look at the numerator, we have an r squared, a 2, and a pi, and the denominator we have a 2, so we can reduce these 2's out, and that gives us pi r squared, which is what I was hoping we would get. So the area of a circle is pi r squared, and we can show that using this formula. To find the arc length, we say s equals r times theta. And again, remember that theta is in radians. We would substitute r for r, and theta would be replaced with 2 pi. So if we rewrite this, it would be 2 pi r. Notice that 2 pi r is circumference of a circle. So it is a direct relationship, and I think it's interesting that when r is a variable, it looks exactly like the formula for the area of a circle and the circumference of a circle. If we wanted to find the area of the sector and arc length of angle 60 degrees in a circle with radius of 15 meters, so r is equal to 15m, 15 meters, we know that the angle we're interested in is 60 degrees. So if I were to sketch the pizza wedge shape that is the sector, the area of that sector is equal to 1/2 r squared theta. And remember that theta is in radians. So I need to convert 60 degrees here to radians. So I'll take 60 degrees and multiply it by the conversion factor. I want to get rid of degrees, so I'll put the 180 degrees in the denominator and pi radians in the numerator. Then I will divide out the little degrees here just to keep track that now I'm in radians, and then reduce. So this is equivalent to pi over 3, and that's in radians. So theta is pi over 3 radians. And now I can do a substitution. I know that r is 15 meters, and I'll just rewrite everything. A equals 1/2 15 squared times pi over 3. So I have a calculator process here, and I'm going to leave pi by itself. As soon as I multiply in pi, it's going to make this a very ugly number. So it's easier to just leave the pi alone and calculate all the numbers separately. 15 squared divided by 2 times 3 is 6. So I'll see if I can turn that into a fraction. So it's going to be 75 halves times pi, and this is meters squared. So this is the area of the sector. Now let's look at the arc length. Arc length S is equal to r times theta. We have 15 times pi over 3. So if I think about this, I will have 5 pi. Now remember, this is meters, not radians anymore, because I'm using this as a length. So if you think of the angle as pi over 3 and the radius as 15 meters, then thinking of this distance here, 60 degrees, I should be able to calculate approximately, just by looking at this, approximately that distance. So if I say 5 times approximately 3.1, that's going to be 15.5 meters. And that makes sense because if you look at the scale here, you would expect that the radius wrapping around here would be about 15. So that's good. We calculated a good number here. Now, sometimes your book will want you to round this. Sometimes they'll want you to leave it as pi. It's kind of up to you, trial and error. I think once you practice this a few times, it will become a little more obvious how you want it to look.